Hi, I'm TJ Vasquez, a Senior Technical Customer Success Manager here at Edge Delta. In today's demo, I'm going to show you how to reduce observability costs through logs to metric conversion within Edge Delta's telemetry pipelines. If you've worked with telemetry data at enterprise scale, you know firsthand how quickly costs can spiral when shipping terabytes or even petabytes of log data into expensive platforms like Splunk or Datadog. With Edge Delta's intelligent telemetry pipelines, you can combat growing log volumes by more efficiently optimizing data upstream before sending it into expensive indexing. Converting logs into lightweight metrics, for instance, allows you to significantly reduce data volumes without losing critical visibility. Configuring log to metrics conversions in an Edge Delta pipeline is a breeze. We're going to walk through a few simple steps on how to leverage this concept within Edge Delta pipelines. First, let's go ahead and access a pipeline. The pipeline we're currently viewing is an Nginx demo source that is ultimately being sent downstream into Splunk. However, we do know that a large portion of these logs don't need to be preserved in full fidelity. For instance, maybe I don't need detailed information on logs capturing events with a successful status code of 200 through 299. I really only care about how many times these events occur. So in order to create our 200 status code logs to metrics processor, I'm going to go ahead and click edit mode here. By doing that, this shifts us into edit mode where I can start to interact with the different processors that are already here laid out. You'll notice that we have a filter that essentially is already passing only 200 logs through a certain route within this processor. So what I'm actually going to do is kind of clean up this route here, and I want to actually add in my new processor. So I'm going to hit add processor and then type log to metric. And you can see that is found here in the analytics section. So once I add this in, I'm going to give it a quick logical name called 200 logs. And then the pattern is going to be dot star because we already know that everything going into this log to metrics processor is already going to be a 200 event. So then I'm going to name this 2xx count. And I want to go ahead and give this a quick enabled stat of sum. I'm going to hit save changes and then wire this back up. So I'm going to drag my filtered logs from the logs to metrics processor into the 200. And ultimately, I'm going to send this to the Splunk mapper. We also need to reconnect the unmatched, but we're going to go ahead and bypass the logs to metrics processor. Once this is done, we can hit review changes and hit save. And this is our new pipeline that now has the logs to metrics processor. Once the node is configured, we can send this metric downstream to Splunk and feed dashboards and alerts, all while significantly reducing data volume for being actually indexed in Splunk. Let's go ahead and view an identical pipeline where this is already configured. From here, we can actually see that this 200 status code route is sending about 374 megabytes of data. But after that data processes through our logs to metrics processor, that data footprint is actually being reduced to 5 megabytes, which is about a 98% optimization. So that's that much less data that you're storing in Splunk and then having to dashboard and alert on to actually extract value out of that data. So by metricizing noisy data sets, you can significantly compress your log data while preserving visibility into your systems and environments without incurring heavy processing costs. That's it for me. Thanks again for watching.